In this video, I'm going to find these derivatives. Now first, recall that these are two things we know when we see something that looks like a power. So we know that the derivative of x to the n is n x to the n minus 1. That's when n is a constant. And we know that the derivative of a to the x is a to the x ln a when a is a constant. The key here is that we know this when n is a real number, and here when a is a real number. And here a is greater than 0. But we're trying to find the derivative of x to the secant x, and it doesn't fall into either category, right? Like neither of these are constant functions. So we have to be careful here. So what we do in a situation like this is we can take the log of both sides. So we're going to do logarithmic differentiation. So ln of y is ln of x to the secant x. And the reason this helps us is because we know that we can now use the log rule to rewrite that as secant x times ln x. And now I can go ahead and differentiate both sides implicitly. So I get 1 over y times y prime is equal to, and now on this side I've got a product, secant x times ln x. And the derivative of secant x is secant x tan x, leave ln x alone, plus leave secant x alone, and the derivative of ln x is 1 over x. And I'm solving for y prime, so y prime is going to be y times all of this. So I've gone ahead and multiplied the right-hand side by y, but I know that y is x to the secant x. So I should return an answer completely in terms of x. And that's my derivative. Next, let's work out this one. Again, remember that this one doesn't fall into either of those two categories that I listed at the beginning of the video. So I need to use logarithmic differentiation. So I'm going to rewrite this. Ln y is ln of 1 plus x to the sine of x. And now I can use the log rule, which brings the exponent down. And now here I should be careful because you might be tempted to pull this through, but logs, of course, do not distribute through addition. So just keep that in mind and avoid that temptation. This is not true. All right, so we need to differentiate now, and I'm differentiating implicitly. So I have 1 over y times y prime is equal to, and here I need to use the product rule. So reminder, if I'm thinking of the product rule, this is my f, and this is my g. And so I take the derivative of f, the derivative of sine x is cosine x, leave g alone, and leave the sine of x alone, and now take the derivative of ln of 1 plus x. That's 1 over 1 plus x. And the chain rule, if I take the derivative of 1 plus x, that's just 0 plus 1. So that doesn't add anything to this. So now I solve for y prime. Y prime is equal to y. So I've got y prime is equal to y times all of this. And now my last step, well, y is equal to this, and I should return an answer completely in terms of x. So this is y prime is equal to 1 plus x to the power of sine x times cos of x ln of 1 plus x plus sine x over 1 plus x.